Why is LMTD critical for cooling system design? Imagine trying to fill a bucket with water when the flow rate changes along the way. It's tricky to get an accurate picture of how much water actually transfers. That's similar to what engineers face when designing cooling systems. They need to know how heat moves from one fluid to another. Here is where the logarithmic mean temperature difference, or LMTD, comes into play. It helps engineers understand the real driving force behind heat transfer in a heat exchanger. Unlike just taking the temperature difference at the inlet and outlet, LMTD considers how that difference changes along the length of the heat exchanger. This makes it a more precise way to measure the effective temperature difference. When designing a cooling system, knowing the right heat transfer rate is essential. If the calculation is off, the system might be too small and won't cool properly, or it could be too big and waste energy. LMTD helps prevent these mistakes by giving a clear picture of the average temperature difference that actually drives heat transfer. This is especially important because different flow arrangements like parallel flow, counterflow, or crossflow change how heat moves through the system. Using LMTD, engineers can compare these setups accurately. It also helps in sizing the heat exchanger correctly, ensuring it can handle the required heat load without wasting resources. When the LMTD is calculated correctly, it makes predicting the outlet temperatures of the fluids more reliable. This helps ensure the cooling system meets the process needs and operates efficiently. Without LMTD, engineers might overestimate or underestimate the heat transfer capacity, leading to systems that do not perform well or cost too much to run. It's also worth noting that LMTD assumes steady operation and constant fluid properties, which matches most cooling system conditions. This makes it a dependable tool for designing systems that are both effective and economical. So, in simple terms, LMTD is vital because it provides the most accurate measure of the temperature difference that drives heat transfer, helping engineers create cooling systems that work reliably and efficiently.